that's the hack.
Yeah.
Alright, you can take a mic out if you want.
I guess I'll do it. Because I like to walk around even though I can send
And live captions.
I'm always impressed by live captions. How do you do that?
So, yeah, 10 minutes. 5?
Yeah, 5, 3, 2.
Yeah.
What?
If 10 minutes is the most important, so in order to slow down or to speed up.
Yeah, 0.
I'll ignore this one. Didn't see that one.
Yeah. Well, whenever you're ready.
I'm never ready, so.
Never ready.
Always and never.
Hi everyone, I hope everybody had a good lunch and warmed up a bit. Next 30 minutes outside, we're going to enjoy Sam's talk. So Sam's going to talk about the future of authentication, so take it away.
Thank you all for coming out. So, my talk is going to be about the future of authentication, but also mostly about I hate passwords. Is there somebody in this tent who likes passwords? Nobody. That's good because I'm going to bash a bit on passwords, and if you like them, then that would not be that nice. So, let me quickly introduce myself. My name is Sam Bellen. I'm from Belgium, and I'm a developer advocate engineer at Auth0. If you've never heard of Auth0 before, we're an identity as a service provider, which basically means that we try to make it as easy as possible for anybody to implement a secure authentication, so you can focus on building your actual products. I'm a Google developer expert, which means somebody at Google once decided that I know something. And I organize a few meetups, Frontiers in Belgium, and the Identity Institute meetup in London. If you're a Londoner in Belgium, come join us, we're nice people. And you can find me on the internet as Sam Bellen. Also, you can npm install me if you want to know more about me, because this is a JavaScript conference. So if you npx something about me, you'll find some information about my websites, my social media, the links to these slides, whatever you want. I have cat stickers, so if you like cat stickers, who doesn't like cat stickers, right? Just send me a picture of a cat, a dog, any animal is fine, or just contact me after this talk, and I'll happily give you some stickers. But that's enough introduction. Let me just get started with the real talk. So a quick summary, what I will be talking about today. A bit of history on passwords, so we're going to see a bit of history, where they've been used throughout history and in technology. Some different types of passwords, so you can define what a password is, because I want to base on passwords, so I also have to say what a password is exactly. A bit about passwordless, and last but not least, the Web Authentication Api, which is a new API implemented in most browsers, which might get us to get rid of passwords altogether. So, a bit of history on passwords. Somewhere before Christ, which is more than 2,000 years ago, I don't know the exact date, but it has been found out by some historians that the Romans used passwords. I guess they use passwords all over the world. This is just an example. So if you imagine that you were a Roman legion and you would encounter another group of Romans, you would ask, what's the password? If they got it right, you would go out and drink some beer together. If they got it wrong, you would fight until the death. So Romans used passwords to distinguish friend from foe. A bit later, somewhere in the 10th century, there's this famous Arabian story, the story of 1001 Night, about 40 thieves who would go out and steal a lot of gold and jewels and stuff, and they would hide them in a cave. And the way to open that cave was to say "Open Sesame." And basically, "Open Sesame" is a password. So if you wanted to enter that cave, you needed to know the password "Open Sesame." Let's skip forward a bit to 1961. A very clever guy called Fernando Corbato, who worked at MIT, invented something called a time-sharing system. Now, in the 60s, not everybody had a laptop on their desk or a phone in their pocket. They had one computer at MIT, but everybody wanted to use that computer. So they invented a system that everybody got more or less 4 hours to use that computer, and to kind of secure your files on that computer, you would use a password, so you could use your own files, but not the files of somebody else, because you would share the computer. Going to the 70s, Robert Morris Sr. invented hashing, which means that the first 9 or so years of computer science passwords were not encrypted but stored in plain text. If you know something about passwords, that's something we don't do anymore these days. And then in the 90s, hacking became more of an issue just because the internet exploded. Everybody was on the internet, every company wanted to have a website, but we didn't know that much about security on the internet yet, so people tried to hack passwords and hack websites. So that's a bit of history on passwords. Let's see a few different types of passwords. But firstly, what is a password? To me, a password is basically anything that's a shared secret. Doesn't matter what it is, as long as I know it and the other party, you or you, and I want to do something with you secure, that can be a password. It's mostly a string, especially on the internet. Password 1234, please use something else. My first password was cold dog, because I had a friend who had hot dog as a password. I was like, I can be more creative, so I chose cold dog. You don't have to use this, try this anymore, because I don't use it anymore. Usually a password is something longer, often a random string, if you want to be a bit more secure. But the first type of password is basically just a string. The good thing about this, or the bad thing about this is, it can be really hard to remember, especially if you have a complex password like this. I don't know any of my passwords. I use a password manager, so they can be hard to remember. But if you use a password manager, that makes it a bit more easier. But it also means that they can be hard to guess by others, because nobody will guess that this is my password. It's just random stuff. So that's one of the plus sides of using a string as a password. Next one, a PIN code. We all know this from using our banking cards or our phone SIM cards, or sometimes when you want to enter an apartment building, you have to enter a PIN code as well. And it's often 2, 3, 4 digits you have to enter, and that basically is also a password. And the bad side about that is they're not so hard to guess, because they're just a few digits. There's only X amount of combinations that's possible, so guessing that is a bit harder. But they're often combined with something physical, like your banking card or your SIM card or the lock next to your door. So without access to that physical thing, that PIN code is useless. So combining these two things, you basically have two-factor authentication in a way. It makes it a bit more secure. And they're fairly easy to remember. Most of us, I think everybody of us, can remember our PIN code on our phone, otherwise your phone would be useless. So that's one of the upsides of using a PIN code. And like I said, they're usually paired with something physical like your cards or your lock or whatever you want. A pattern. Who has an Android phone and uses this to unlock their phone? Nobody. Awesome. Who's ever seen this on a phone? Most people. That's good. And basically what this is a pattern to unlock your phone, and this pattern is also just a password, and it usually translates to some kind of password, a PIN code or something in the back. And people use this a lot because it's very convenient, but it often reveals a pattern on your touchscreen. So if you have a touchscreen on your phone and you do the pattern over and over and over again, you might see some dirty spots of what the pattern actually is. So that can be a bit tricky about using this as a password. And people often use their lucky number or the initial of their name as the pattern, so that might also be easy to guess for others. But it's easy to remember, it's just a pattern. You can also, if you do it a lot, it will become part of your muscle memory, so you'll start doing it automatically. So that's very convenient. So what's the problem with passwords? We have this little login form, and I think we all know this. You see this on any websites these days. And when you want to log in, you just type your password and click login. But of course, from the first try, you're always wrong. I cannot type my password from the first time. So you try the second time, and now it should be right. Second time, wrong again. Third time's the charm. Let's try it one more time. Login. No. So what you do is you're like, okay, I forgot my password. I'm going to reset my password. So you reset your password. You type a new password that you're happy with, and then you get something like this. Who's happened this before? I've had this happen before. You think you forgot your password, you reset it, and it turns out you just are not capable of typing very well. So this is annoying. Passwords are not that user-friendly, they're not that secure, and they're very annoying to use. This guy. It just sums up my feelings towards passwords. This one emoji. Passwords can be very annoying to use, can be very annoying to remember. If you use a password manager, it might help you with this scenario, but you still have to use some external software to keep them secure, to input them. You have to have it on your phone, on every device you use. I can recommend it, but it's still an extra step involved with using passwords. Also, user data can get stolen. Last year, I think this was data from 2018, Google lost a lot of user records. All of this didn't contain the actual passwords, but it did contain some personal data. Facebook, through Cambridge Analytica, 87 million. Quora, 100 million. MyFitnessPal, 150 million. You can see it going up. Marriott Hotels lost 500 million private records. Also, no passwords, but still, it means that people are actively trying to steal data from companies. If somebody decides to store passwords in plain text, which still happens, Google recently had to announce that they did it for a few certain select clients, they would be able to steal your passwords and would be able to steal your accounts. So, like I said, from the 90s the web is growing and people start hacking, and passwords are a weak link in this system because once somebody gets access to it, they can hack your account, or they don't even have to hack your account anymore, they can just enter your password. At .0 we have this nice functionality that kind of warns you if your password has been included in one of those data breaches. So if you wanted to log in with a username and password that has been known to be stolen before, you will get an email saying that please change your password because it's been breached before. And also Google has a plugin for Chrome. If you want to install this plugin, it does basically the same. It just tells you please change your password because it has been stolen before. So a few tips for good passwords. Use a complex password. The length is more important than the randomness, but combined, both of them make a stronger password. Don't use anything personal, because if you use the name of your mother or of your dog, people can just figure it out from using your Facebook account or whatever. Don't reuse passwords. This means use a new password for each website. Can be annoying to remember. Again, a password manager can help you with that. But don't reuse passwords. And then change them frequently, which means that every year, every half a year, you should change all your passwords. Nobody does this. I also don't do this. But if you want to be really secure, that's a tip that I can give you. Okay, we've seen passwords through history. We've seen all the different types of passwords. We've seen that it's annoying to type passwords and that nobody really likes them. Let's fast forward a bit again. Let's go to passwordless. Who here uses passwordless solutions in their day-to-day life? Like 1, 2, 3, 5. I see some more hands. Okay, so passwordless is getting a bit more mainstream, but it's still not there yet. So let's have a look at what passwordless is. The first example of passwordless is a one-time password. And the good thing about that, it's valid for one time, like the name says, a one-time password. Once you've used it, it becomes invalid. It often expires after a certain time, so they're often just valid for half a minute, 1 minute, 2 minutes, and then they expire. So if you don't use them fast enough, they expire as well. And they're sent directly to the user. They're sent by the service for which you want to authenticate straight to you. This can be in an SMS. And the good thing is that if you use an Android phone or an iOS phone and you get one of those SMSs with a one-time password, you will see something like this. And as you can see on my keyboard, I can just tap on the message and my one-time password will be entered directly. I don't have to type the number separately, which is very convenient. But not all telecom operators take security serious, so SMSs can be intercepted. That's one of the downsides of this. And apart from using an SMS, you can also just send them, you need your cell phone by hand. Like if you're logging in on your laptop and you get an SMS, you just have to find your cell phone, which is maybe upstairs or in another room. It can be a bit annoying. You can also send them in an email. So instead of getting an SMS, you get an email with a one-time password. If you use Slack, you might have seen this email me a link, the magic link feature. Who's used this before? I see a lot of hands. And that's just because it's easier to click on a link to log in than to type your password and your username. So this basically just sends you a link, and this link contains a one-time password. You click on it, the password expires, but it also will log you in. Again, you usually don't need a second device because you might have your email set up on your phone, on your laptop, everywhere that you're working on, any device you're working on. But emails can also be intercepted. Anything basically can be intercepted, SMS, emails, so that's always the weakest link. Let's assume that doesn't happen, but just to be complete, I mentioned this anyway. Next one is an authenticator app. Anybody uses the Google Authenticator app or anything else? Perfect. At Zero, we also have the Guardian app, which does the same. It generates one-time passwords. And there's a bunch of others out there. Duo has one, LastPass, Authy is another famous example, and even Microsoft has an authenticator app. And what they do is they just create these one-time passwords for you. They're often time-based. Like the Google one, the passwords are valid for 30 seconds, and then you get a new password every 30 seconds, which means that it's a bit more secure. You cannot use them forever. In the app, your numbers become red, and you apply thingy on the left side, right side, become smaller. They're often push-based as well. Like you just get a push message from this app, you click on it, and ta-da, you're logged in, so you don't have to type or copy and paste these one-time passwords anymore. But they rely on a shared secret between you and your service you're going to use and the app you're using. So if the secret gets leaked, you could be in a lot of trouble. But that's with every secret that gets leaked. It's never a good thing. Then again, social. We use social login to log in once in a while. A few hands, a lot of hands. I think the reason why most people do this is just because it's convenient. You already have a Facebook account or a Google account or whatever, a LinkedIn account, so you don't want to create an account for every website, so you just use a social login to log in because you already have that account. And the good thing about it is it's one less password to remember. You only have to remember your Gmail account, for example, that password. And you only give this password to a service you trust. If you use login with Google, it kind of means you trust Google, even though we've seen that they lost a lot of personal records in a few slides back. But I think the general consensus is that we trust Google or Facebook or any of these big companies to store our data correctly. So you only give your password to them and not to some exotic app you just want to try out because you're logging in with Google, not with that app. But they rely on another service. This means that if those services go down, you cannot log into any of the other services. If Google goes down for some reason, you cannot log in with any of the services implemented login with Google. Some other authenticator apps, It's Me, something Belgian. Yodi does some facial recognition, it works very well. VoiceState uses your voice, that's voice recognition to log you in. So there's a lot of different options going from one-time passwords in different formats to doing fancy stuff like facial recognition and voice recognition. And that's all under the umbrella of passwordless. But they're often used as a second factor these days. So these days, you often just log in with a password, and then as a second factor, you use these one-time passwords. Just because there's some issues for using this as a first password, it does make your account more secure, but you're still stuck with passwords for the first factor. Luckily, there's this new API that's called the Web Authentication Api. Has everybody ever heard of this? There was a talk about it yesterday as well, so you might have seen that talk, which is really cool. It's often abbreviated as Web Authn, so if you want to Google some more information about this new API, Web Authn often has more results than the complete name, the Web Authentication API. And basically, what this is, it's a key-based authentication mechanism. It means that you have a private key and a public key, and you only share the public data of your public key with others, and your private key remains securely stored for yourself. It relies on hardware authenticators, and there's a whole bunch of them, going from some fancy thing with a screen, some Bluetooth ones, NFC ones, USB-A, USB-C ones, even an open source one which you can hack if you're into that. So they rely on one of these little machines, and the only thing that these do is store and create new credentials. You cannot get those credentials off them. They are securely stored on those devices, and they do nothing else. It's not a regular USB drive where you can just send your cat pictures. You cannot do that. It just stores the credentials. Like I said, you have them USB, you have them Bluetooth, you have them in NFC, so you can use them on your phone as well if you want to use Bluetooth or NFC, because not all phones have a free USB port just to use this authenticated device. So who has one of these? One person, 2 persons, 3 persons. And that's annoying, because if you have one of these, or a login example from before would look a bit like this. We just enter a username, Like I said, we want to get rid of passwords, so we don't have a field to log in with a password anymore. I have one of these connected to my computer, and if I click on login, my browser will ask me to touch it just for some security. It's pin code protected, which is kind of password, but you don't have to do this. Touch it again, and allow it because I'm on localhost. But when I do so, it's going to do a lot of magic things, which I'll explain later. But basically, I get some data back from the authenticated device and some public key information as well. So I could log in with just using this authenticated device instead of typing in password. I already asked who has one of these devices, and I think there's 3 or 4 hands. Now, who has a device, a mobile phone, a laptop, that's younger than 10 years? I think everybody has a recent model, right? And the good thing is that most modern devices, most modern chipsets have a dedicated chip that does exactly this as well. If you have a modern Intel chipset or AMD, or your Apple has this, I think it's called T's chip, I'm not sure what the name is, but they do nothing more than create and store credentials securely. So if we have the example we had previously, again, we're just going to click on login. But instead of touching my external USB one, my laptop is going to ask me to do the same action. And because my laptop has Touch ID, I can unlock this chip with Touch ID. So now the router asks me, can you please touch your Touch ID? I do that and allow it because I'm on localhost. And I get the same result as before. This means that I just logged in by just using my Touch ID built into my device, which is pretty neat. No need to type, no need to remember your fingerprint because you already have a fingerprint. It just works like that. So that's really cool. And how does this work? Because we've seen that I get a pop-up with some random stuff in it, but let's explain how this actually works. The first thing you need to do is create a new credentials. Like when you create a new account on a new service, you usually just created a new password. Instead of doing that, we're going to create a new set of credentials, which means we enter a username and then send that to the backend. It will store it somewhere, and the backend, your authentication or authorization server, will send you a challenge. A challenge you can just see as a random bit of data. It's usually an array buffer with some random data, which then gets forwarded by the browser to your authenticated device. And that authenticated device will create a new set of credentials, a new private key, a new public key, and we'll use that private key to do something with that challenge, to sign that challenge. Usually you have some user interaction, like touching your authenticated device, doing the Touch ID, or if you have Windows Hello, face recognition, face whatever it's called. And after this user interaction, we send the signed challenge together with the public key and the ID of your private key that actually signed the challenge, and we can store all of those data in our backend. So we don't store the passwords anymore, we just store the public key, the signed challenge, and the ID of the private key. And the ID of the private key is just so we can find that private key on our authenticated device next time the user wants to log in. So we send it back to your backend, your authorization server, whatever, store it in a database. If this gets leaked, it's not that bad because it's public data. Of course, you don't want to do that, but if it's a bit less bad. So the next time the user wants to log in, we're already registered as a user, we already registered our authenticated device. So the user just enters a username, which we're going to do a lookup in our database. We're going to see, oh yeah, we have some credentials created for this user. So we send the public ID back to the authenticated device. The authenticated device is going to check, do I have a private key with this ID? If so, I'm going to sign the challenge and send it back after some user interaction to our backend. And based on the public key data we saved before, we can then determine that it's the same private key that signed the challenge. This means that it's the same user that just came back and that the user is allowed to enter your application. So to recap, to register, you request a challenge. It's an array buffer with random data. You sign that challenge on your authenticated device with a newly created private key, and then you send back the raw ID of that private key, the public key information, and the signed challenge to your service or whatever you want, wherever you want to use it, and you save this somewhere in a database, somewhere persistently. The next time, if you want to authenticate, if you want to log in again, you just request a new challenge, and you request if you have some raw ID saved for this user. Send this raw ID together with the challenge to the authenticated device. Use the same private key to sign the challenge again, and then determine if that private key is being the same as the one you saved before. So let's look at some code, because it's a JavaScript conference, so I have to show some JavaScript at least. To create new credentials, there is the navigator.credentials.create method. This is a browser API, so this is exposed by browsers. And it accepts a bit of config, some JavaScript variables in the public key. And the first part is the challenge. Like I said, some random data, so you just pass along a challenge. Next up is some information about the relaying party. This is often the website you're signing in or registering for. In this case, my own personal website. Next up, some information about the user. A user ID, his name or display name, whatever you want. And then the allowed credentials. And this means that you basically have a whole bunch of algorithms that these authenticated devices may or may not support, or that you may or may not support in your backend. So you only want to accept the algorithms that you know how to work with. So in this example, you use -7. -7 is not really an algorithm, but if you look it up in the COSA list of algorithms, you can see that it's ES256. So in this example, we will use ES256 as one of the algorithms that we know how to work with. So we know that our challenge is going to be signed with that algorithm. A timeout, how much time the user has to actually perform all the actions needed, touch ID or touch the authenticated device, and so on. And then if you want to exclude certain credentials for some reason, that's possible. And lastly, some information about the authenticator. So if you only want to accept external ones, like the USB or Bluetooth ones, that's possible. If you only want to accept the internal ones, like the Touch ID, it's also possible. You do that with the authenticator attachment, set it to platform, only internal one, built-in ones to your devices. Set to external, it's only external ones, USB, NFC, Bluetooth, whatever. You can choose if the device needs to be able to verify a user. Touch ID verifies that it's me. My little USB thingy that I touch verifies that somebody does it, but it doesn't know that it's me who touches it. If anybody can come and touch this USB drive or USB device. So it's not really verifying the user, it's just verifying that somebody is doing something. And lastly, you can require resident keys, which we'll see in a minute. And the last option is attestation. Basically, if you want to anonymize the data sent back from the authenticated device to your service, yes or no. Sometimes you just want it to be very anonymous, and other times you want it to be a bit less anonymous. Once we've registered these credentials, we saw that we want to use it again to log in every time the user wants to log into your service. And for that, we're using navigator.credentials.get method, same thing with config. A challenge, because we always use a challenge. Then we're going to pass along all the allowed credentials. And this is basically the credentials we saved in our database. This is going to be the raw ID of the private key that we have on our authenticator device, together with some other options. And then again, we can say if we want user verification, yes or no. Now, resident credentials, and this is where it really gets interesting. Up until now, we still had to enter our username every time we wanted to log in. We saved our credentials somewhere in a database connected to our service. But it would be awesome if we could just store this user information together with our private and public key, or private key on our authenticator device. And that's possible with resident credentials. So if I would go to webauthn.me, this is a website we created, and basically it allows you to play around with this API and test a lot of different things. So if I would enter, let's say, Tokyo as my name, and then Tokyo as my display name as well, and if we would check the require resident key, what we're going to do now is we're going to register a new credential for the name Tokyo, for the user Tokyo, and we're going to save them on our authenticator device. I'm choosing the built-in one, so my Touch ID, I touch it, and once I do so, I get a lot of data back. So you can still store, and you should still store this data in your database, but because we checked that, or because we use the require resident key option, we can now also just authenticate. So instead of sending one back in the allowed credentials, we can now just authenticate, and this means that the browser is going to check if there's some saved credentials on the authenticated device, and you can just use it if you want to use it. So let's try that again, but with a bit of more time. We click authenticate, do Touch ID, and we get a list of all the stored users on my authenticated device for this website, because it's based on your URL, your origin. And I just created Tokyo, so now we can just log in with Tokyo by clicking on it, and we get some more information back. So this means that we don't even have to ask the user for the username anymore. We just defer all of this information, all of this thing to the browser. It just gets saved either on the authenticated device or on your laptop. You do this by require resident key setting it to true. If you want to play around more with this debugger, webauthn.me/debugger, it basically allows you to change any of this config and see it on the fly, so you don't have to set up a test project. Some issues to be solved. I'm going a bit faster because I have 3 minutes left. User credential management, you cannot change the users saved on your authenticated device. You can delete them all, but you cannot change them. So if you want to do that, that's still not possible these days. If you want to share them across devices, unless you have an external one that works with both your laptop and your phone, you cannot use them with both your laptop and your phone. So if you use the internal one with Touch ID on my MacBook, I cannot transfer that one to my phone, for example, or to another laptop. This means that if you lose or your device gets stolen, you're in some trouble, so you always need to have a second factor which will allow you to recover your account and log in again. So WebAuthn might replace passwords. I think it does. It's still in the early stages of this. It does not replace OIDC or OAuth or any of those things because that's not part of the actual logging in. That's what happens afterwards. And it's W3C recommendation, which means that it's a finalized spec. It's standardized. And it works in all modern browsers, even in Safari 13, which was launched in October. So you can all start using this on your services today, or already for a while actually. So where can I use this? Google supports it, GitHub supports it, Dropbox supports it. A lot of the bigger services already allow you to log in with the Web Authentication Api. We have some blog posts about it. Webauthn.me is the website that I showed earlier. It gives you some more information, allows you to debug or play around with all the options. Also, it's an interactive tutorial that lets you see what goes on between your server and the authenticated device. So let's summarize. Boo passwords, nobody likes passwords. One-time passwords are cool, but WebAuthn is way, way cooler because you don't need to do anything except register, and that's it. Webauthn.me, the spec is surprisingly readable for a spec, so if you're into that, give it a shot. I wrote some blog posts about it as well. Come talk to me after this talk if you want to know some more details as well. And the slides can be found at 1990.somedigo.tech. So if you want to see the slides again, you can always go to that URL. That being said, thank you.
Thank you very much, Sam. That was great stuff. Up next will be Claudia Hernandez talking about the future of package management.